Okay, guys, greetings. Let's look at these, and I'm going to do some of them here. I'll pull some of these over here. So let's look at this. Um, First, solve these equations. I see logarithms, so I'm gonna isolate, rewrite, and solve what's left. And let me rewrite this really quick. I've got log base 2 of x plus 1 equals 3 minus the log base 2 of x plus 7. Okay, so to isolate this, I'm going to add this log over here. So I get the log base 2 of x plus 1 plus this log base 2 of x plus 7 equals 3. And I put I added that together because now that they're on the same side, I can use my properties of logs. And the property I'm thinking of says that if I have a log plus a log, I can multiply their insides and combine it into one log. So this becomes x plus 1 times x plus 7 becomes uh, x squared plus 8x plus 7, and that, of course, equals 3. Now, from there, so I've isolated it, I simplified the inside, I can rewrite 2 to the power of 3. So moving over, 2 to the power of 3 is 8. So 8 is equal to x squared plus 8x plus 7. I'm going to minus my 8 from each side, and I get 0 equals x squared minus 8x minus 1. Um, hmm. Hold on. This doesn't feel right for a second. I'm just going to go back and check. I wrote it down right, added that over, multiplied this, xx, 1, 7 is 8, 1 times 7 is 7. Okay, that works. And then 2 to the power of 3 is 8. So 8 equals that inside. Yep. Okay, now I'm looking at that. That's not going to factor. So I'm going to do quadratic equation. X equals uh, negative 8 plus or minus the square root of negative 8 squared minus 4 times 1 times the negative 1 all over 2 times 1. So that's going to give me 8 plus or minus square root of, you know what, this is where I screw up when I do quadratic formula. So I'm going to go 8 squared because that's negative 8 squared. Minus 4 times 1 times the negative 1. That gives me 68. So I'm going to actually simplify this. 8 plus the square root of 68 over 2. And I end up getting 4 plus or minus the square root of 17. 4 minus the square root of 17. That's a negative something. So now I'm just checking for extraneous. 4 plus the square root of 13, I know won't give me any problems if I add 1 to it or add 7 because it will be positive. 4 minus the square root of 17, that's a negative 0.1-ish. That won't give me problems either. So I believe that's my answer. Okay, so at this point, guys, I'm actually going to check for something really quick because I realized I don't have the Weber State answers up here, and I wonder if my answers match their answers. You guys have them, but I don't. So I'm going to log in really quick onto their Canvas course and hurry up. I'm going to go to exam 3 and I'm going to print out their solutions, or at least bring them up so I can have them there. Goodness sake, it's taking me a long time. Download is still processing. There it is. Oh. Now. I missed something. Or they missed something. So they're saying I missed a negative. So let me double check that. Where did I do it? negative b. Oh, you know what? Know what? They're right. They're right. They're right. Why did I do a negative 8 there? So I should have positive 8, positive 8. So this should be negative 8, which makes this negative 4 minus square root of 10. There. And see, there's where I was, excuse me, there's why I was checking for the extraneous prior to this is because if I have a negative 4 minus the square root of 17, see, negative 4, that's a big negative number because square root of 17, that's bigger than 4. So, and if I put a negative 4 minus square root of 17 in for this, or frankly for this, it's going to give me a negative number. So negative 4 plus the square root of 17, that's the only one that's going to work. Okay, so the recipes for this: isolate, rewrite, solve what's left, and then if it's logs, I've got to check for extraneous. I've got to do that. Okay, so let's look at something else for a second. The next problem, 1b, that's this one right there. I've got 2 times 49 to the power of x minus 11 times 7 to the power of x plus 5 equals 0. Now, this is a really curious one because we didn't see very many like that. We didn't see very many problems like this. Here's my thing. It's exponential, but I'm thinking the only way I can combine exponentials is if the base is the same. So, excuse me. Only way I can do that is if the base is the same. So I'm thinking, how can I do this? Well, I know 49 is this times 7, that times 7, or 7 times 7, which is 7 squared. So let's look at it this way. 2 times 7 to the x squared. Because, see, this is 7x squared, which means I multiply these, 7 to the power of 2x, and 7 to the power of 2x is 7 squared to the power of x. So there's that. Minus 11 to the power of 7x plus 5 equals 0. So I'm thinking, See, I've got 2 times 7 squared. So I'm going to say, you know what? Let's do something else. 2a squared instead of 7x. Everywhere I see 7x, I'm going to put an a. Minus 11a plus 5 equals 0. Now I can solve that. In fact, I think I might even be able to factor it. I know this is going to be 2a and a, and it's either got to be 5 times 1 or 1 times 5. Well, if I put a 5 over here, 5 times 2 is 10, and 1a, 1 times a, I think that's going to be right. It's going to be negative, negative, since I need to find factors of 5 that add up to the negative. So let me check myself. Negative 1a, that's negative 1a. 2a times negative 5, that's negative 10a. That makes the negative 11a, equals 0. So now I can look at it and say, a is equal to the opposite of 1, opposite of negative 1, which is positive 1 over 2, or opposite of negative 5. So 5 minus 5, or 5. Great. Except I was never really answering. I was never really, I was never asked, to solve for a. I was solving for x. But see, I put a in place of 7x. So really, I just found a to the x is equal to the 1/2, not a to the x. 7 to the power of x is equal to 1/2, and 7 to the power of x is equal to 5. So I rewrite that now. X is equal to the log base 7 of 1/2, and x is equal to the log base 7 of 5. And I could put those in a calculator and get it. Now, if I don't have a calculator to deal with log base 7, I can go, let's do x equals the natural log of 1/2 over the natural log of 7, and x equals the natural log of 5 over the natural log of 7. Remember the change of base formula? That if you take the log of the inside over the log of the old base, that's the same thing, right? So that's that. Let's look at C. Let's look at C. C is that one. 5 times 3 to the power of 8x plus 6 equals 800. This looks pretty straightforward. I got to solve. I solve, rewrite. Well, let me see. I got to isolate, solve, rewrite. So I'm going to isolate that, which means I get rid of the 5. Divide by 5. What's 800 divided by 5? I don't trust myself right now. 800 divided by 5 gives me, oh, look at that. My lights turned out. 160. So I've got 3 to the power of 8x plus 6 equals 160. Okay, now I can solve that. I'm going to rewrite that as a log. Log base 3 of 160 equals 8x plus 6. Now, guys, you have to realize that's a number. I don't know what that number is, but I can put it in my calculator. So I'm going to just, I'm going to subtract 6. Subtract 6, that'll be gone. So log base 3 of 160 minus 6 equals 8 times x. Then I'm going to divide by 8, and I'll divide that whole thing by 8, and I get x is equal to that. Okay, so I could type that in my calculator. Again, if you don't have the log base 3 button, I could go the natural log of 160 over the natural log of 3 minus the 6 all over 8. And if I put that in my calculator, I should get something like, hold on, I got to turn on my lights. Sorry, guys. If I sit in that chair long enough and don't talk or don't move over here to the corner of the room, my lights turn off. So there we go. Now my lights are on. Okay, so now let's put that in the calculator. And hopefully I'll get the right thing. Or hopefully I'll match somewhere. So I'm going to go log base 3 of 160 minus 6 all over 8, and I get negative 0.1725 something-ish, which is exactly like negative 0.173. Okay, there's that. Cool. Okay, moving on. Now, I will tell you, these problems, they give us kind of the hardest problems we're going to see, so that's kind of cool. Okay, so let's look at this. So you got to match this up with the stupid angle I write. There we go. Okay, so the next problem, 1D, 2 to the power of 3x plus 1 is equal to 5 to the power of x plus 2. Okay, now I'm going to solve this. Yuck. See how I have two bases? Now, like when I went a couple of times ago, I had two bases, 49, 7, but I could rewrite 49 as a power of 7, and then I could solve it like that. But there's no way I can write 5 as a 2 to the power of something. Well, I guess we could, and I remember somebody did it in class the one time. That was pretty cool and interesting. The way I was envisioning it is take the natural log of each side. And now I have, and then what I can do is I can pull this out on each side. So then I have 3x plus 1 times the natural log of 2 is equal to x plus 2 times the natural log of 5. Okay? Then I can distribute this through here. 3x times the natural log of 2. And I'm going to actually check this around. I'm going to go x times 3 natural log 2. Okay, so you just multiplied these and left the x out. I'll show you why here in a second. And then plus 1 times the natural log of 2, so plus the natural log of 2 equals x times the natural log of 5, so x natural log of 5 plus 2 times the natural log of 5. Okay, so see my x's here? My x's here are there and there. I need them on the same side. And see these things that are not x's? I need them on the same side. So I'm going to take this, I'm going to move it over here. I'm going to take this, I'm going to move it over there. So then I'm going to get x times 3 natural log of 2 minus x times the natural log of 5 equals 2 natural log of 5, because it was already there on the right, minus that, minus the natural log of 2. Okay. Now, see how there's an x here and here and here? X in both of these? If I factored that x out, all I have is 3 times the natural log of 2 minus the natural log of 5 equals this whole thing over here. Then I'm just going to divide by this 3 natural log of 2 minus natural log of 5. And I get x is equal to that thing, which if I put that as a decimal, I'm going to get about 5.374-ish. Okay? So I'm looking for something like that will give me this. Okay. Whew. Now, let's look at something else. Number 2 here. Suppose money is deposited in a savings account and earning this compounded continuously. That tells me I'm using my PERT formula. So all of a sudden, I'm looking, there's my rate. Suppose money is deposited. I don't know how much money, so I don't know my P. And how long will it take? I'm looking for my T to double. So I want this doubled. Oh, that's not too bad. So here's what I'm going to do. I know that I'm dealing with PERT, so I'm going to go A equals PERT. And I'm finding time. I'm told the rate is 8%. So e to the 0.08 times t, but what I need is I need an amount, and I need double that amount. So here's what you could do. You could put in a p, and then this would be 2 times p. Or you could put in 5, and this would be 10. You could put in 1, and this would be 2. Either way, doesn't matter what you put in, because the first thing you're going to do, and I'll just do this, is you're going to divide by whatever that principal is to isolate your exponential there. That's going to cancel, and that'll cancel, and I'm going to get 2. See it? If this was 5 and that's 10, you would divide by 5. 10 divided by 5 is 2. This was 1, that would be 2. 2 divided by 1 is 2. So you're going to get this as long as this is doubled whatever you started with. Doesn't matter. Now this is isolated. Take the natural log. Natural log of 2 is equal to 0.08 t, and divide by 0.08. And there's what I get. Okay? A natural log of 2 divided by 0.08. Oops. Natural log of 2 divided by 0.08. And I end up getting t is equal to 8.664. And this is years, since my time is in years. And there's what I'm getting. Okay? Now, look at this. This is the same thing, except 8% annual interest rate, compounded every 3 months. So that tells me I'm using the formula A equals P times 1 plus R over N to the power of N times T, where P is the principal, R is the rate, N is the number of compoundings in a year, and T is time. Okay? You need to know both of those right off the top of your head. You need to know them. You got to know them. Can't get around it. Okay. So let's look at that for a second. So I need new paper. Okay, so I know I'm looking at this model. A equals P times 1 plus R over N to the power of NT. and I'm told that it's 8% annual interest rate, and I'm wanting to know how long to triple. So I'm going to do P and 3P. I could do 1 and 3. I could do 10 and 30. I could do 5 and 15. As long as this, whatever is there, is 3 times that. Then I'll put this in 1 plus the interest rate is 8%. And it says it's compounding every 3 months. How long does every 3 months happen in a year? Well, at 3 months, 6 months, 9 months. Oh, and then again at 12 months. So that's 12 divided by 3. That's 4. 4 to the power of 4t. There's my model. Now to solve it, divide by p on each side. And that cancels, and I'm going to get 3 equals this whole thing, 1 plus 0.08 all over 4 to the power of 4t. Okay, at this point, just so it's easier to see, I'm going to put that in a calculator. 1 plus 0.08 divided by 4 gives me 1.02. Oh, that's not too bad. 3 equals 1.02 to the power of 4t. Now I need to rewrite it as a logarithm. So I'm going to go log base 1.02 of 3 equals 4t. Now if I just divide by 4 on each side, and I get t equals that. Now, if you don't have a log base 1.02 button on your calculator, you could do the natural log of 3 over the natural log of 1.02, and then you could take that and divide it by 4. Okay, but I'm just going to type in just what I've got. Log base 1.02 of 3 all divided by 4. That gives me 13.8695, so 13.870. And that is going to be in years. Okay. That's number 1. Number 1 is done, or 4.5 is done. Let's do section 4.6. Section 4.6. And this is all about models. So there are 2 models you need to know, and we've already looked at them. This one and one from before, that one. Okay, so 4. I'm looking at 4. Compounding continuously. So this is PERT formula. I see a rate, I see a starting amount. So I'm going to put in that model. So situation number 1. A equals 800 times e to the 0.06 times t. Okay? And, oh, look, it says there's another guy. He puts 1,200 earning 4% compounded continuously. So it's the same thing. A equals 1,200 times e to the 0.04 times t. And it wants to know at what point will your accounts have the same amount of money. Well, that just means when does that equal that? So when does 800 e to the 0.06 t equal 1,200 e to the 0.04 times t? Okay, how am I going to do that? Excuse me. Well, oh, I see something. Check this out. What if I divided each side by 800? Let's try that right now. That would cancel, and I'd get e to the 0.06 t equals, that's gone, 12 over 8. I think that's 1.5, isn't it? 12 over 8, 12 eighths. 12 divided by 8. Yep, it gives me 3 halves, 1.5. So 1.5 e to the 0.04t. Now, what if I divide now by the e 0.04t? Check this out. That's gone, and I get 1.5 equals. Now, remember when I had a power divided by power, and their bases were the same? Remember what I could do with this? Yeah, I could subtract them. What's 0.06t minus 0.04t? If you said 0.02t, you would be exactly right. Now I've isolated that, so let's rewrite it. So natural log, since it's base e, of the 1.5 is equal to 0.02t. And if I divide by 0.02 on each side, I get t equals that. Natural log 1.5 divided by 0.02. That gets me this. T equals 20.273. And since this is in years, 20.273 years. Yikes. Okay. Okay. Let's look at my next one. Population was this much in 2000. Doubling time is observed to be 23 years. Find the model for the year after year 2000. When is it going to be 175,000? So this is just a generic growth model. So it's going to be like the PERT formula. If you want the really nice formula, A is equal to A sub 0 times e to the k times t. Okay, and it tells me in year 2000, it was 105,000. And then doubling time. Well, doubling time means time is something. What does it say? Doubling time is 23 years. So after 23 years, I got twice as much as that. Well, that's 210,000. Right? Yes. Okay. So that gives me an equation I can solve. Okay, so I'm going to divide by the 105,000 on each side. That's gone. And I get 210 over 105. I don't know what that is. 210 divided by 105 gives me, 2. Why didn't I see that? 2. Oh, because it's doubling. Duh. E to the k times 23. Okay, so natural log of 2 equals 23k. Then I divide by 23. And so I get k is equal to the natural log of 2 over 23. Natural log of 2 over 23. My lights just turned off again. And I get 0.030136 something. Let's just go 4. Okay, so now my model is A is equal to 105,000 times e to the 0.03. No, yeah, 0.03014. Okay, what was I trying to figure out anyway? Oh, when does so there's my exponential model, and it wants to know when does the model predict that my population is going to be 175,000. So I put 175,000 in for that. And from there, I solve it. So I'm going to divide by 105,000. So 175,000.
Seniors, don't forget to buy your cotillion tickets by this Friday at the Bookkeeper.
105,000. Yeah, seniors, don't forget to buy your cotillion tickets. And I get 5/3 equals e to the 0.3014 t. Take the natural log. Natural log of 5/3 is equal to 0.3014 t. Divide by the 0.3014 t equals natural log of 5/3 over 0.3014, which gives me something. Natural log 5/3. Oops. 5/3 divided by 0.3014 gives me 1.6948. Okay. Now, I don't buy that for a second because, well, hold on. Oh, you know what I did? See what I did? 0.03. I forgot that zero. See, the reason I 0.0003. Reason I didn't buy that, if it takes 23 years to double, and this is just short of doubling, but it's not that short. It's going to take me close to 23 years. So if I do that natural log of 5/3 divided by 0.0314, there we go. I get t equals 16.948 years. And there it is. Okay? Okay. Let's look at something else. This next problem talks about bacteria culture. It says bacteria culture starts with 5,000 bacteria. After 2 hours, it's 9,000. So this is, and I want to know when it's going to be 20,000. Okay, so start at 5,000. And then, so this is t equals 0. T equals 2 is 9,000. And I want to know t equals what for 20,000. Okay, so it's going to be this whole formula again. A equals a sub naught times e to the k times t. And here, this is 5,000. Let's put in the 9,000, because the 9,000, I know that, and I know not k, but I know t is 2, because it tells me after 2 hours. Okay, so there's what I'm solving. And I'm trying to find k. Come on in, guys. I'm trying to find k. So if I divide by 5,000, sorry, people want to come in for a second. 9,000 or 5,000. That's 9/5 equals e to the k times 2. So if I solve that, natural log of 9/5, I rewrite it as a log, equals k times 2, divide that by 2, and there's my rate right there. So if I put that in my calculator, natural log, not tangent, natural log of 9/5 divided by 2 gets me, k is 0.2939. I'll just round to 4 decimal places to write it. I'm probably going to leave that in my calculator and just let it sit there for a second. So now I want to know, when is it going to be 20,000 bacteria? So I got to go 20,000 is equal to 5,000 times e to the this 0.2939 t. So And guys, this is getting a little tedious because I'm doing the same thing. I'm dividing this out to isolate, and then I'm rewriting it. So I'm going to divide by 5,000. 20,000 divided by 5,000 is 4, equals e to the 0.2939 t. Then I can rewrite this as a natural log of 4 is equal to this 0.2939 t. And then I'll just divide by that 0.2939 on each side, which is sitting my calculator right there. So I'm really going, what's the natural log of 4 divided by that answer? And I end up getting t is equal to 4.717. And that's its, and the units were hours. So those are hours. Wow, 2,000 to 20,000 and 5,000, 20,000 in 4 hours. A little over 4 hours. That's why bacteria in your body are so nasty, because they multiply so very fast. Okay, last one here, and then I'm going to pause and make a new video recording for the next sections, or a couple of sections or something. Okay, so after 5 days, so let me look. This is a half-life model, so it's the same thing. A equals A0 e to the k times t, except its half-life after 5 days contains 60% of its original amount. Okay, so if I look at this, I'm going to go A0 e to the k, but it just told me at 5 days. So 5, and this is 60% of where I started. So as long as this is 60% of this, doesn't matter. I mean, I could go 160. I could go 10 and 6. I could go 1 and 0.6, because the first thing I'm going to do is dissolve out that starting amount, and I get 0.6 is equal to e to the k times 5. I'm going to be done with this in just a few minutes, guys, okay? So now I'm looking at that, and it's already isolated. Let's take the natural log. So natural log of 0.6 is equal to 5 times k. And if I divide by 5 on each side, I get k is equal to that. So there's my k. There's my rate. Natural log of 0.6 all over 5, right? Right. Which is that. K is equal to negative 0.102165. It's that number. Okay, now that's important. K is negative. That's important because I knew that because it's decaying, right? It's getting smaller. And see, look what it's asking me. It's saying what is the half-life? Well, half-life is just the time until there's half of it left. So let's look at this. A sub naught, and I want to know where's half A sub naught. Now, I want to point this out for a second. I'm trying to find the t, right? Let me erase this. And my rate is this negative 0.102165. So I'm trying to find that. Now, check this out. Here, we wanted 60%. And look at what we had. We had natural log of 60% divided by 5, divided by that time. Imagine I'm doing this. 1/2 divided by that, and I'm going to get 50% or 0.5 or 1/2 equals this. Then I'm going to take the natural log, and it's going to end up taking the natural log of that 1/2. But it's going to be equal to that times that. So I'm going to take the natural log of 1/2, and I'm going to divide it by this 0.102165. And that's going to equal t. Okay? Now, reason I want to point that out is look at the next thing. It says, how long will it take to decay to 10%? So that's just going to be 10% of what I started with equals what I started with to e to the negative 0.102165. It's the same thing as up here. It's the same thing as up there, except you're always ending up with the natural log of what's left here, half, here, 10%, divided by whatever number is here. in this case, it was time that gave me the rate. But now I'm doing rate that's going to give me the time. So that's that negative 0.102165. That's going to give me my t. That's calculator problems. So I'm going to go natural log of 0.5 divided by that answer that I just had sitting up there. So here I'm getting t equals 6.785. And here, see, I'm just going to go up in my calculator until I get this same thing. I'm going to equals, there we go. And then I'm just going to go the natural log of 0.1 over the answer. And I'm going to get this 22.538 years. Okay, so that's what I'm looking at. So now, guys, think about the models that we've used. We've used this model here. That's just a generic exponential growth or decay. We use that on a few things. But then for money, guys, you need to know your compounding at a certain times per year, but you also need to know your compounding continuously formula. Those are formulas you're always going to use for exponential growth and decay. Okay, so next one we'll move on to 10.1. But for right now, that is our logarithms and exponential applications and stuff. Pause. See you next time.